Hi folks, Mr. Long here. We're going to do a screencast today on solving systems of equations using matrix methods. And this is, what it's going to be is putting matrices into what are called row echelon form. It's a totally different way of solving systems of equations. Like think of grade 10 academic when you did two equations with two unknowns, right? That's what we're talking about. And we're going to extend it this year to three equations and three unknowns. The approach that I use, this matrix form, is quite helpful for anyone from business to biology, where you might use this in statistics, to, of course, engineering, physics, math, anything like that. So it's something that students do come back and say, I'm glad that you took that approach. So, and we're also going to use some technology too, some spreadsheet work to help us solve these. So let's get going. So first of all, we need to define what systems of equations are. So what are systems of equations? Well, system, the word system means there's more than one, right? So here's an equation here, here's an equation here. A system is more than one thing that work together. So a system of equations. And then what are we looking for? Well, what we're looking for, like what is a solution to a system of equations? Well, that's when the x and y values are the same in both equations. And, I mean, I can let x be 5 in this equation, and then there's a certain y I can let, or 2, or whatever. Let's see. Maybe we can just fill in some tables of values and see if that will help us understand what a system of equations is. So, for example, if I plug in 3 here for x and y add up to 6. Well, so that's got to be 3. If this is 4, if x is 4, it has to add to 6. That's a 2. If x is 5, 5 plus 1, okay, is 6. Now let's look over here. Let's look at x minus y equals 4 and see what we get. So x minus y, 3 minus 3 is 0. 4 minus 2 is 2. 5 minus 1 is 4. Well, which of those is a solution to the system? Well, looks to me like, 5 minus 4 is, 1. And let's see, 4 minus 2 is 2. That doesn't seem right. 3 minus 3, 4 minus 2, 5 minus 1. 5 minus 1 is in fact 4. Okay, so 5 minus 1 is 4. So all of these, so this does not subtract to 4. This does not subtract to 4. This does, right? So that's 5 and 1 works for both, okay? So 5 and 1 works for both. So that's the solution to a system of equations. All right, so a solution is when the variables in the equation are the exact same and the equation is still true, okay? The equation is still true. All right, so that's what a system of equations is. So how are these two equations related? X plus y equals 3 and 2x plus 2y equals 6. I don't know if you remember, but one of the ways that we solve systems of, or how we graphed before is what we did is we just said I'm going to get the intercept. So I'm going to let y equals 0, then x equals 3. Then I'm going to let x equals 0 and y equals 3. And that, not 0, 3. And that would give us the intercepts. So that right there is 3, and that there is 3. What if I now take x and multiply it by 2 to get 2x, y and I multiply it by 2 to get 2y, and multiply 3 also by 2 to get 6? How is that equation? Like the equation looks different, but is it an equivalent representation? So this time I'd let 2x be 6, x-intercept would be 3. I'd let 2y equal to 6. And 6 divided by 2 is 3. It's the exact same graph. Okay, they're equivalent representations. And that's important, you're going to see when we do, when we solve these equations, because we're going to be multiplying equations by a number. So this equation and this equation represents the same set of ordered pairs. So they're equivalent equations. Okay, they're equivalent equations. All right, finally, let's get on to doing some work that you've done before. So here's a system of equations, and in this system of equations we have the relationship that 16x minus 12y equals 20, 6x plus 1y is 13. And we're going to find out the solution to that system of equations. So what pair of numbers, x and y, will satisfy both equations? Okay, there's only one of them. There's only one pair of numbers that works in both equations to make both equations true. So the left side equals the right side. So we're going to use the method of elimination that you learned in grade 10. So how do we do that? Well, the first thing I always do when I'm doing a question like this is I look for a common factor. Is there a common factor in that equation so I can make it simpler? Well, common factor is definitely 2 because they're all even, but then I should check 4, and it does work. 4 is a common factor. So I can divide that entire equation by 4. Okay, the entire equation by 4. So what do I get? 16 divided by 4. 16 divided by 4 is 4. Negative 12 divided by 4 is negative 3. 20 divided by 4 is 5. Okay, that's still equation 1. By the way, I'm calling this one equation 1, the second one equation 2. So then what we want to do is, once I've got that negative 3 there, what I need to do is I need to get the coefficients the same to eliminate. Okay, so I need to get these numbers the same, the 4 in one equation equivalent to the 6 in another. So if I look at this equation here, so I look at that equation there, how could I get the coefficients the same, either x or y? Well, 6 is not a multiple of 4, so that's not easy math. But negative 3 is a multiple of 1. What would I multiply this equation by to get a 3 here? Well, I think I've sort of highlighted it here. Multiply by 3, okay? Multiply that equation by 3. So if I multiply equation 2 by 3, we're going to go down now to here. So now I'm going to multiply, the first equation stays the same, 4x minus 3y equals 5. And now I'm going to do 3 times 6, that's 18. 3 times 1, that's 3. 3 times 13, that's 39. Now what do we notice? We have that situation. Can we now eliminate? So when the coefficients are the same, we can eliminate. By the way, why can't I multiply this equation by 3? Why is that allowed? Because as I just showed you, it's the same graph. Okay, it's the same set of ordered pairs. Multiplying an equation by a constant or dividing by a constant doesn't change anything. Okay, so what I'm going to do now that I have the same coefficient, right? I have negative 3, well, opposite. I either want the same or opposite coefficients. So am I going to subtract those equations or add them to eliminate y? Well, I'm going to add them, of course, because negative 3 plus 3, if I add that together, I get 0. So what do? We add 4x and 18x to get 22x. We add negative 3y and plus 3y to get 0. And we add 5 and 39 to get 44. So now I have a new equation. That new equation is 22x equals 44. Can I solve it now? Yeah, divide both sides by 22. And then x ends up being 2. How do I go back? I back substitute to get my other equation. So I go all the way back up to equation number 2, this one here. And now that I know what x is, I can replace x with 2 and solve for y. Okay, so I'm going to replace x with 2 and solve for y. So I have 6 times 2. Well, what's 6 times 2? 12. So 12 plus y is 13. So let's look at that. Let's think about that for a second. So that's 12. 12 plus y is 13. Okay, what do I add to 12 to get 13? 1. Okay, so x equals 2, y equals 1 is the solution to that system of equations. All right, now we're going to do this in a totally different way that's sort of related. So we're going to solve the same system of equations, but now what we're going to do is we're going to do it by what are called row operations. So I'm not going to use x and y anymore. I'm just going to use numbers, the coefficients and the constants. So here's what we do. So we're going to take this set of equations right here, and what I'm going to do is I'm going to put those equations, turn equations into rows in what's called a matrice. So this box that you see is a matrice. Okay, it's also known as sort of a two-dimensional array, an array of numbers. I know you haven't worked with matrices before, so this is new. So I'm talking here about, the first part is talking about leading ones, leading coefficient of 1. That would mean if the number in front of x was 1 or a number in front of y was 1, or plus or minus 1. If you have that, you should put it in the first row. Okay, so you should always put it in the first row. So it looks to me we've got a leading 1 in this right here. So what I'm going to do now is I'm just going to put the coefficients in here, coefficient matrix. So it's going to be 6, 1, and 13. Okay, so that had a 1 in it. I always put a 1 in the top row. So now let's see if I've got it. If I don't have a 1, I don't. And then what do I put underneath it? I put the other equation. That's going to be 16, negative 12, and, whoops, not 13, but 20. Okay, but 20. So what I want to do now is divide out any common factors. So is there one of those rows? So again, you just have to pretend that this right here is an equation. You read that as 6x plus 1y equals 13. But we do it with just the numbers. It's actually more efficient. Okay, it's more efficient. So this is the position of x, this is the position of y, and this is that constant. Okay, so this right here is actually an equal sign. Okay, so can I common factor row 2 in this case? Yeah, I can. I can't common factor row 1. So what this says here is row 1 equals, or the new row 1 equals the old row 1. So the new, the old, divided by, well, by 1. I can't change anything there. So that's going to be 6, 1, and 13. There was no common factor. But in the second row, 16, negative 12, and 20. Well, that's 4. Okay, I can divide everything by 4. Then I end up with 4, negative 3, and 5. Okay, so now what I do is I look at that and I go, okay, if I look at this row here and I look at this row here, is there a way that I can get one of the coefficients to be equal to each other? Okay, so a pair of coefficients. So can I get 6 and 4 to equal the same thing through multiplication or division? I could, but I'd have to work with both of them. This one here is a multiple. Negative 3 is a multiple of 1. So what could I do to row 1 to make it to be 3 or negative 3? And you know, why would I pick either one? Well, it's probably easier to make it 3 and then I can add to 0. So what I'm going to do is I'm going to take row 1 and I'm going to multiply it. I'll circle multiply by 3. Okay, multiply by 3. So the new row 1 is going to be the old row 1 multiplied by 3. So let's see. I multiply that by 3. 6 times 3 is 18. 1 times 3 is 3. 13 times 3 is 39. And then I've got the second row. Okay, and in fact, well, row 1, I just multiply by 1, right? So I can just put 4, negative 3, and 5. Okay, 4, negative 3, and 5. So now what can I do? Right, what can I do? I'm going to eliminate. You always want to eliminate in the second row. Okay, always eliminate in the second row. So we're going to, our new row 2 is going to become, so what do I need to do? I need to take this original row 2, and what am I going to multiply it by? 1, it's just plus or minus 1, and then I'm going to add it to 1 multiple of row 1. And for this year, we're going to do the work separately so that these numbers will always be plus and minus 1. In university, you'll try to do things much more efficiently, so you'll combine these two steps into one step. But for this year, just to make it a little more manageable, we won't combine those steps. Unless you see it, if you can see how to do it yourself and do it, that's perfectly fine. Okay, so next, I need to add. 18 plus 4 is 22. 3 plus negative 3 is 0. 39 plus 5 is 44. And you have to remember what that means. Okay, what does that actually mean? That means 22x, because this is x, this is y, and this is the constant. And this right here is an equal sign. So what do I need to divide that entire row by? Well, I'm going to divide that entire row by 22. Okay, divide that entire row by 22. And notice I don't need row 1 anymore because I've eliminated a variable. So I divide everything by 22. 22 divided by 22 is 1. 0 divided by 22 is still 0. 44 divided by 22 is 2. And that gives me a solution. This is x, this is y, this is the constant. X equals 2. Okay, how do I get my answer? Oh, I should have put that here. R2 divided by, I didn't need to do that. R2 divided by 22 is what I should have said there. So, oh, again, by the way, folks, this is the new R2, and this is the old R2. Okay, so x equals 2, how do I figure out y? Same way, now it's the exact same question as before. I go back and I look at what's the simplest form of a row. Well, the simplest row was that one there, 6x plus 1y equals 12, and I use that to solve. So 6x plus 1y equals 12. Okay, and I'm going to put x equals 2 in there. So I would replace this x with a 2. 6 times 2 is 12. 12 plus 1y equals, is it 12 or 13? Oh, it was 13, sorry, that makes more sense. It was 13. So 12 plus y equals 13. Y equals 1. Okay, and that's my solution. Again, you're going to see this again, but the pattern is the same every single time. And I know it seems like a lot of work, but trust me, this is the best way to solve systems of equations with these matrices. And you will get used to it, okay? You will get used to it. And you're going to be doing it with computers too, so that's going to make things a lot faster. All right, let's look at this one here. Actually, we'll look at this one in the next video, okay?